Hello, everybody. We're going to do a lecture today on Booleans and conditional statements. So before diving into that, just a note on variables and their names. So generally in computer science, we like to make our variables helpful, make our code readable. It's actually one of the lines in the Zen of Python. So it's always good to name your variable something short, but something that clarifies what you're referring to, like first underscore name, last underscore name, instead of A or B, for example. When you're doing your variables, it needs to start with a letter, like A to Z, or an underscore. Now you can have words separated by an underscore like this, or you can have camel case where you capitalize the first character of the second word. In Python, the underscore thing seems to be more popular like this, but I am totally fine if you want to use camel case, and I will be using both throughout the class. You can't have a space, so you need to have an underscore if you want to separate words. You can't start with a number. You can't have special characters. And it's not a good idea to use a Python keyword, which we looked at a couple of lessons ago. All right. So now I'd like to introduce a new data type to you, which is called a Boolean. So a Boolean is essentially a mathematical expression that evaluates to true or false. So it has two possible values, true or false. So let's just get ourselves a bit familiar with Booleans. So if you want to open up your terminal, go into your interactive mode, and let's just, and when you're using true or false, you always have to do a capital T or a capital F. So you can see here, you can see that it's a class bool, so it's a data type Boolean. But if I try to do a lowercase t, it wouldn't recognize it. So just be sure to do your capitals. Sorry, I had to pause because I had to cough. Okay. So Boolean variables can only be true or false. They have to be capitalized. So let's have a look. Let's assign this variable can vote equals true. And then we can say type can vote. You can see it's class bool. Let's try this one. So we could say my score equals 100. So this is obviously an integer. Your score equals 99. This is another integer. But we could set I1, this variable, to a Boolean by saying like my score is greater than your score. And you can check I1 and you can see it's true. If we wanted to say my score is less than your score and we would check I1, we would see that that would be false. So we can also assign Booleans like that. And we just use relational operations. So here, for example, you can see that we use greater than, less than, greater than or equal to. So these are important, less than or equal to. And this is something that it's very important for you to learn. Two equal signs means just equal to. We'll have a look at that. And exclamation equals equal means not equal to. So, for example, if we say 3 is greater than 4, that's obviously false. But we can also use a float. So we can say this float is less than that float. That is true. We can use greater than or equal to. And here is our equal to with the two equal signs here. So for example, if I said my score is equal to your score, that would be false, right? And then we also have not equal to, so we could say my score is not equal to your score. That is true because they are two different scores. Right. We can also use these in string comparisons. So remember, a string is a sequence of characters inside quotation marks. And if you remember back to, I think, our second lecture, we talked about how characters are stored with numeric codes. So capital A to capital Z is represented by these numbers, and lowercase a to lowercase c is represented by these numbers. So we can actually compare characters to see which one is less than or greater than the other one in terms of alphabetical order. So we know that A is represented by 97, and we know that B is represented by 98. So we could say, A is less than B because 97 is less than 98. So this way we can actually alphabetize our characters. So for example, if we wanted to see, does Mary come before or after Mark? If we wanted to do a string comparison, would this be true or false? So let's have a look. So this is actually from the textbook as well. So what it would do is the program counter would go and it would check each character of the words. So it would start with the capital M, and those are both the same. So it would compare the next two characters. And it would check, they're both A. So we go to the next one, they're both R. So we go to the next one. But here Y is represented by 121 and K is represented by 107. So 107 is less than 21, but here we're asking if Mary is less than Mark, and you can see that it is not. So if we were to run this and we were to say Mary less than Mark, it is actually false because Mary is greater than Mark because Y is greater than K. So you can use these with string comparisons. So now we move on to control structures. So far we've been using very, very simple control structure. We're just doing sequences. So we've just said things like, what is your name? What is your age? And then we print something. But we could actually do something a little better, where we check if something is true, and if it's true, then we carry out something. So sometimes we want certain action performed if, depending if a certain condition is true. So for example, in this class, if you get 93% or higher, you will get an A. So we can represent that with this decision structure. So here we have our Boolean. So we have greater than or equal to 93. So if this is true, you would get an A in the class. In this case, if it's false, nothing happens. So this diamond shape represents some condition. So this is a Boolean. So we have to see if it's tested, if it's true or false. If it's true, then the student receives A. If it's false, there's no action. So we can use if statements to do this kind of decision, to make this kind of decision. So if we just have a very simple if statement, we can have a single alternative decision structure, just like we looked at. So this is important, and we're going to do lots of examples of these. So don't worry, we'll come to this. So you need to have an if keyword, space, and then some Boolean, so some condition that has to evaluate to true or false. and we have the colon, and then we have an indentation. So you can do a tab. We'll do that together. Then you'll have whatever statements. So if this is true, then you'll do whatever statements are inside here. So let's have a look at the example we just looked at. So for example, if we have a variable called grade and we set it to 93, and if we say if grade is greater than or equal to 93, colon, print, and here's the indentation, print, you got an A in class. So we have a Boolean expression here, grade is greater than or equal to 93, and the code inside the indentation only executes if this Boolean expression evaluates to true. If it evaluates to false, nothing is going to happen. So actually, let's try this with a really simple script. So, go ahead, I'll put in 93. If grade is greater than equal to 93 colon, and then indent with a tab. So don't spacebar, just do one tab. Print, you got an A in class. So let's go to our terminal. Exit out of this mode. Let's clear that. And let's cd. So you need to cd into your correct directory. And let's put this into week 3. And you can pause and do this in your own time. And then we're going to run, and you can call it if.py, and then we're going to run it. So you can see here, you got an A in class. Awesome. Now let's change the grade, and let's make it less than 93. So if you got 91, and we run it again, then nothing happens. So that's where it's not greater than or equal to 93, and we don't have any other situation at this point where anything happens. Okay. Here's another example. So if we have two variables, x and y, we can say, if x is greater than y, print x is greater than y. If x is less than y, print, and if x is equal to y, print x is equal to y. So you can try those in your own time. And I just thought it would be nice to hear a little snippet from Bill Gates. He's going to be talking about if statements. So I'll play me.
People make decisions every day. For example, before you go outside, you kind of have an if statement that says, if it's raining, then I need to get my jacket. And computers are amazing once you decide those kinds of statements, that they can reliably execute those things at unbelievable speed. And so a computer program really is a little bit of math and some if statements where the decision gets made. So in this puzzle, the if block helps the zombie make a decision. It checks something. For example, let's use the block that says, if there's a path to the left, and put a turn left command inside it. So we're telling the zombie to check its surroundings, see if there's that path on the left, and if so, make that turn. And then we use the move forward block inside this repeat to get it to keep moving forward as long as it just wants to go straight. Then when there's the turn, the if block will tell it to make this turn to the left. And you can see if we do that, if we're taking the turns to the left and otherwise moving forward, we'll achieve our goal. So it's an example of using an if statement, which is really a fundamental concept in computer programming. One of the first things I learned was how to write a program to play tic-tac-toe. And so I had if statements to say, okay, if the other person's about to win, go ahead and block that spot. So have fun learning how to use if statements. It's a key concept.
Great, thanks, Bill. Okay. Now, we also want to add something to this, which is the if-else statement. So the if-else statement will execute one block of statements if the condition is true, And if it's false, it will execute another block of statements. So what do we mean by this? So if it's true, you will get an A in class. But if this Boolean is false, then we're going to print something else. We're going to print you don't get an A in class. So the way if-else statements work is you have the regular if, and then it's really important you have the if and the else aligned. And the else doesn't have some Boolean condition. It's just else colon, and then you indent, and then you put in what you want them to do if this is not true. So let's have a look at a concrete example. So we were saying if the grade is greater than or equal to 93, print you got an A in class, else print you didn't get an A in class. So we have if some Boolean expression, the code that executes if this is true. If this is false, we're going to skip this line altogether and go straight to the else and then execute this line. So let's do that in Sublime together. So you're going to add 2 lines to your code. So you're going to have if grade, da, 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 and then you're going to have the else that aligns with the if, and then you're going to say else colon, and then an indentation with 1 tab, print you did not get an A. So let's have our grade be less than 93 and run this again. And this time you can see instead of nothing, you actually get a print statement that says you did not get an A. Okay. So with the previous example we just looked at, we could have said if x is greater than y, print x is greater than y, else print x is less than or equal to y. So we haven't quite got to the third clause yet. We will cover that soon. And I think it's important to stress here that the else is an optional part. So like you saw, we didn't have to have the else. We could have just had the if. At nested conditionals and the elif else statement. So there's 2 different things here. So as you know, we just did our if statement. We also saw that we could do an if else statement. Now let's look at nested if statements. So you can actually nest if statements inside other if statements. So here's an example. Let's look at a Python program that determines whether a bank customer qualifies for a loan. In order to qualify a loan, the customer must meet 2 conditions. They must earn $30,000 per year, and they must have been employed for at least 2 years. So this is from the textbook. If you look at the decision structure, it could look something like this. So the salary needs to be greater than 30,000. If it's false, then we can already print you must earn at least 30,000. But if this is true, we need to have another decision to see, to check this Boolean. Do they have more than 2 years on the job? If this is true, then they can qualify for the loan. But if this is false, then we must print you must have been employed for at least 2 years to qualify. So we could do something like this. Now, here at the top, these are variables and they're capitalized because they're constant variables, so that's denoting that they shouldn't be changed. So we have the min salary and the min number of years. And then we ask them for input. So we say, hey, enter your annual salary, and we convert it to a float data type. We ask them for the years on the job, and we convert it to an int data type. And then we check if their salary is greater than the min salary. Now I've aligned this if else together in green and the nested if else in orange. So the first thing we're doing is checking, like we did here, is the salary greater than or equal to min salary, which is 30,000. If it's not, straight away we can just jump to the else and we can print you must earn at least, and then we put in the dollar and the format min salary per year to qualify. And you can see that here, if it's false, we just print that straight away. Now, if this is true, we want to do another check. So here is the nested if-else statement. So then we say if years on job is greater than or equal to min years. And if it is, then we can say print you qualify for the loan, which is this bit here. So we're checking, this is the nested and we're checking this here. And if this is false, we jump straight to the else and we print you must have been employed for at least 2 years, which is this line here. So this is the code for this diagram using a nested. And in this case, we're using a nested if-else. But you could just have a nested if statement inside of an if, or you could have a nested if statement inside of an else. Because remember, your else is optional, so you don't need to have an else. But in this case, we had both if-else inside of the if. So this is going back to our example using variables x and y. So we could say if x is less than y, print as x is less than y, else, and then here is a nested if else. Else if x is greater than y, print x is greater than y, else print x and y must be equal. So this if else is nested inside of this else. So that's nested if and nested if else statements. And then we also have the elif or else if. So this is a very important one, the if, elif, else statement. So this actually allows a simpler type of logic because you can see the other ones above are a little bit more convoluted. So for example, we could say if something is true, condition 1, then we just do whatever's under the if. But maybe we want to check another condition. So we say elif condition 2. And this stands for else if. So we say else if another condition, then do whatever's inside there. And we can have as many elif statements as we want. And we'll look at some examples, don't worry. And then at the very end, we can have an else. And with the else, there is no condition. It's just for all the other cases, do whatever's under here. And the else is optional. So sometimes it's a good idea to have the else, and sometimes it's not a good idea. Oftentimes, it can be a good idea just to catch any edge cases so your program doesn't break. So let's have a look at a concrete example. So this is, I think, a really nice example of making things easier. So instead of using that convoluted, nested if-else that we just used, we could just say if x is less than y, else if x is greater than y, and then finally the last condition, else. So this would be where they would be equal. And you can see that the if, elif, and else are all aligned. And like I said before, you always need some Boolean condition to evaluate to true or false with the elif. Okay. So we can compare the nested conditions with elif. And I think this is a nice example. So we could have a look at looking at your score for a grade in the class. So for example, if your score is greater than or equal to 93, then your grade is an A. Else, if your score is greater than or equal to 83, then your grade is a B. Else, if it's greater than or equal to 73, then it's a C, and so forth. Finally, all the way down to else if the grade is F. So, sorry, else the grade is F. So if you were doing this with nested conditionals, you'd have to do something like this. So you'd have if score is greater than or equal to 93, print I got an A, I love Python, else, and then we do a nested if else, if it's greater than or equal to 83, print else. And inside that else, you have another nested else if, and then it keeps going on. So instead of doing that, we could have a nice clean elif. So instead, we could just say, If score is greater than or equal to 93, print I got an A, I love Python. Else if the score is greater than or equal to 83, print your grade is B. Else if, 73, you got a C, and so forth down to your else where finally, your grade is F. So it's, I think, important to repeat here that only one of these lines will ever be printed. So when you're using these if or if else or if else statements, only one of these lines will be printed. This is different from nested ifs. So if I go back, oh no, sorry, it's not different. Never mind, ignore that. So for example, I can never have an A and a C at the same time, right? I can only have an A or a C. So I think it's important to remember that if this is true, then we just do this line and then we stop. So it's just going to keep checking until it stops. So if this is true, it's going to go to this line and it's going to stop. If it's not true, then it's going to go to the next line and check if that is true. And if it is true, it's going to print this and it's going to stop. If it's not true, it's going to go to the next one and so forth. So that means that your order really matters. So that's something you have to bear in mind when you start working with if statements and conditionals, is that order matters. So what would happen if we change the order of this? Like, what would happen if, say, you had this code instead? So say a student received a grade of 96 out of 100, or here we said 99, fine. If they receive 99 out of 100, what grade would the student get with this code? So let's have a look. So we would have if score is greater than or equal to 73, is it? Is 99 greater than or equal to 73? Well, it is. So you would get print your grade is C, and then it would stop. So it would never get to this one, it would never get to this one, and the code would assign the student a C when they're actually an A student. So this is why the order really matters. So you have to be careful about that. Okay. So now I'll also show you a little, so you can do, if you've done it in class exercise 3, and it's fine if you haven't, you can also do a little bit of in class exercise 4, but you will need to wait for the second lecture on logical operators to do the last question. But let's have a look at some of the questions so you can get started if you wish, but there's absolutely no pressure. We can do this in class together. So this is actually testing if, elif, else statements. So now this program is probably going to be a bit more involved than the ones you've done before. Write a program, convert money.py, that prompts the user like this. So currency to convert to US dollars, and then you give them a whole bunch of options. So you copy all of this in. Depending on which letter the user enters, so they're going to enter E, C, R, or B. Then depending on what they enter, you have to display amount of euros or amount of rupees. You can't display this whole thing. You have to pick one of these currencies. That's what I say here. After the user enters the amount, then you can display the conversion into US dollars. So this is kind of old now, but here are the conversions that you can use. So that's that. That's a bit more involved, so we can definitely help you with that. You can also start on water.py. That asks for temperature in Fahrenheit. The program should accept any floating point number and display whether water is liquid, solid, or gas at that temperature at sea level. So display the results like water at that temperature is a solid, for example. And here are the temperatures where water freezes and boils. And let's do it in Celsius, which is, obviously much better. You get extra credit if you do that. And then this one you'll have to wait to look at logical operators. All right, I think that's plenty for you to be getting on with. And as always, don't worry, we can help you in class, answer questions, and help you with that in class. So we'll leave it here for now.